Hello. Yeah, in this brief video, just want to show you how to compute confidence intervals for the mean, median, skewness, and kurtosis. It's relatively easy to compute confidence interval for the mean. For example, you can call the t-test function to do a t-test. It will compute the confidence interval for you. But what if you want confidence interval for other statistics such as median and skewness or kurtosis? So I just want to show you a way to do it in R. First, let's create a random sample from an F distribution. I choose the F distribution because it's skewed, so its median and mean are not equal. If we do a random sample from the normal distribution, then the mean and median will be the same. Okay, so we're going to set a random seed, 36, and draw a random sample there. Sample size 100, degree of freedom 3 and 7. And the secret weapon for calculating confidence intervals is the R library called confintr, so confidence interval in R. So I'll bring you to the website. So now I'm at the website of this R documentation for package confintr. Okay. So it says here the description: calculate classic and or bootstrap confidence intervals for many parameters such as the population mean variance, interquartile range, median, absolute deviation, skewness, kurtosis, Kramer's V, odds ratio, R squared, blah, blah, blah. Okay. So this is a package that covers a lot of different statistics here. Okay. Actually, not statistics, population parameters. If you have time, you should read through the documentation here for all these R functions. Let me just go to the function to calculate for the mean. Here. So this is CI for the population mean. Okay. Just want to bring you down here, the usage. So you can see it has a couple of arguments. You can specify the probability for your confidence limits. And there are several types of confidence interval: the T interval, the walled interval, and the bootstrap interval. Okay. And as you know, if you have a larger sample size, the walled and T interval should be very close. And if a relatively smaller sample size, you can consider using T, and when you have unknown population variance, then you use T, or it's a really small sample size, you can consider bootstrap. Okay. If you want to do bootstrap, you have to specify boot type equal to studentized, BCA, percentile, and normal, and basic. Okay. And then you can specify how many bootstrap samples you want to do. You can specify a large number here. And if you want, you can specify a seed. Okay. All right. now let's come back to the RStudio session here. So first, let's load the library in here, and then just use the CI mean function. It will give you that confidence interval. If you want to do bootstrap percentile confidence interval, you specify type equal to bootstrap, boot type equal to PERC, R equal to 1000, C equal to 1. So it tells you it's a two-sided 95% bootstrap confidence interval for the population mean based on 1,000 bootstrap replications and the percent method. Okay. So the confidence intervals for the median, skewness, and kurtosis are very similar. Okay. So you use CI median and also CI median with the specification for bootstrap confidence interval. For skewness, you'll notice it took a little longer to calculate confidence interval for skewness. Okay, and for kurtosis, yeah, it's still fast to compute bootstrap confidence intervals. Yeah. Okay, here you have it. I hope this is helpful when you're looking for a way to compute confidence interval for median, skewness, and kurtosis. And also this R package confintr have functions to compute confidence interval for many other population parameters. Thank you.